We're going to continue to look at hypothesis testing here. Now, to formalize stuff, if you have a small p-value, we reject the null hypothesis. The sample that we will get, assuming a null hypothesis for true, is getting that sample or as extreme or more than extreme is really small. It's statistically significant. We have evidence in favor of your alternative hypothesis. So if your small p-value, it's statistically significant and we reject your null hypothesis. If your p-value is not small, we do not reject your null hypothesis, and your sample would not have been too extreme, and it is not statistically significant. And for the most part, you would say your results are inconclusive. It doesn't really show anything to support your alternative or your null. Either one might be true. The results you got don't favor one or the other. So we only have two results. If your p-value is small, we reject the null hypothesis in favor of the alternative. If your p-value is not small, we do not reject the null hypothesis. So only two conclusions. Rejected if your p-value is small, or you do not reject if your p-value is not small. But how small? Well, that's alpha. Our significance level, alpha, is really what you decide on ahead of time. And if that p-value is less than alpha, you would reject. If the p-value is not less than alpha, meaning it's equal to it or greater than, you don't reject. Normally, your alpha, your significance level, is going to be at 0.05, and that's something that you decide on ahead of time. And so once again, it's statistically significant if your p-value is less than alpha, and then you reject. If it's not less than alpha, it's not statistically significant, and you fail to reject. Your results are inconclusive. So suppose your null hypothesis is X is an elephant, because it's always equal to, and is means equal to. Your alternative is that it's not an elephant. What can you conclude? Well, if it walks on two legs, I would probably reject and say that it's not an elephant. However, you can't be certain, because is it possible an elephant can walk on two legs? Yes. Or you might say, oh, it has four legs. Well, you would then fail to reject, but you don't have evidence to say for sure that it is an elephant, because there's lots of animals that walk on four legs, not just elephants. So you can't prove that it's an elephant, but you did not find evidence to say that it is not an elephant. So we never accept the null hypothesis. We just say we fail to reject it. So the lack of evidence against your null hypothesis is not the same as proving it or finding evidence for it. So let's take a look at this example with red wine. And some of you might be needing to take more red wine for this class. Hopefully it's not stressing you out too bad. But this ingredient in red wine and grapes has been shown to promote weight loss in rodents and has been investigated with primates. So we're using lemurs here, and we're going to give them that supplement in the red wine for 4 weeks, and then we're going to look at the results that we get. Now, we want to look at their resting rate, and suppose we ended up getting a p-value of 0.013. Using alpha being 0.05, is it statistically significant? And what would you conclude? Well, since our p-value is less than alpha, our p-value I put right underneath p-value 0.013, alpha's 0.05. That's a true statement. If that statement's true, we would reject your null hypothesis and it's statistically significant. If you reject, it's statistically significant. If you do not reject, it is not statistically significant. So suppose we looked at the mean body mass and we got a p-value being 0.007. Well, if your alpha was 0.05, is it statistically significant, and what would you conclude? Well, our p-value less than alpha, that's what I write down each and every time, and then I put the p-value down, the alpha down, and see if it's true or false. If it's a true statement, we reject your null hypothesis and it's statistically significant. And this is what we would conclude. So suppose we had this one here, where we were looking at locomotion, and we had a p-value being 0.98. Same situation, you have same alpha. Is it statistically significant? And what would you conclude? Well, our p-value less than alpha. I put my p-value down, I put my alpha down. This is not a true statement. So it is not statistically significant, and we do not reject your null hypothesis. And so then this would be our conclusions down below. So suppose we had this situation and a p-value being 0.035. Go ahead and try to do this one yourself and then watch it on the video. So write down p-value less than alpha, put down your p-value underneath, put down your alpha underneath, put the less than. If it's a true statement, then we write down we reject the null and it's statistically significant. If this was a false statement and is not true, it would not be statistically significant and we do not reject. And so then we would make these conclusions in the context of the problem. So if you are at alpha 0.05 or 5% or less, that's to the left, we would reject and it's statistically significant. If you're at 5% or above, you do not reject and it's not statistically significant. Now, we can also go ahead and use kind of some informal words to describe this too. If it's closer to 1%, you would say you have very strong evidence against it. If it's between 1% and 5%, you would say it's strong evidence against. If it's on one side or the other side, close to 5%, you'd say you'd have some moderate evidence against. If it's between 5 and 10, you have some evidence against. If it's a little bit larger than 10, not a lot larger, but a little bit larger than 10% for your p-value, you have a little bit of evidence against. And it might require some more study. So go ahead and read through this situation here. So for each situation, write down your null hypothesis alternative, the informal description, since you're given your p-value here, either for or against, and then your formal description and in context. So go ahead and try to do it for each one of these. So when we're comparing the UV light to MS, which against MS, and we're comparing our UV light to our control group, we had a p-value being 0.02. Your null hypothesis, you could either write your proportion of UV minus your proportion of your control is 0, or you could say that they're equal to. Whether you write it out like we have on the left or write it out like what you have on the right does not make a difference. Now, we actually have strong evidence against it because our p-value was pretty small, as in smaller than 1%. If you look at your p-value being 0.002, your alpha being 0.05, this is definitely a lot smaller than this. So it's a true statement. So we would reject your null hypothesis. We have very strong evidence against it. We have strong evidence that UV light provides protection against MS with a qualifier of at least in mice, because that's what we were testing. Now, when we're looking at the vitamin D compared to our control group, we had a p-value being 0.47. So vitamin D proportion minus your control proportion is 0, or they're equal to each other. Whether you write it out on the left or write it out on the right doesn't make a difference. It was a fairly large p-value, so we have little evidence against it. If you write it out this way, p-value less than alpha, put down your p-value, put down alpha. It's not true, so you do not reject your null hypothesis. It is not statistically significant, and we can't really conclude anything. So when we're looking at what we're doing with these tests, there's only really 4 possible conclusions. Now, if we reject the null hypothesis when the null hypothesis was false or wrong, that's a good decision. If we don't reject the null hypothesis when the null hypothesis was true, well, that's good that we didn't reject it. However, if you reject the null hypothesis when it was really true, that's an error, and that's referred to as a type 1 error. Or if you don't reject your null hypothesis when you really should have because it was false, that's a type 2 error. So here are what a type 1 error and a type 2 error are in the context of the red wine problem. And here's your type 2 error in the context of the red wine problem. So what about in the court of law? So we have our null hypothesis that the person is innocent and our alternative that they're guilty. Evidence must be beyond a reasonable doubt. So your evidence is your p-value. Shadow of doubt is your alpha value. The types of mistakes that can be made. Because a correct decision would be a person is guilty and you convict them. That's a correct decision. A second correct decision is the person is innocent and you find him not guilty. But there are 2 possible mistakes that could be made. You could convict an innocent person. You could release a guilty person. Convicting an innocent person is a type 1 error. Releasing a guilty person is a type 2 error. The probability of a type 1 error, rejecting your null hypothesis when it's true, is your significance level alpha. And so that's the probability of being over here. That's alpha for your type 1 error. Now, for a type 2 error, when you don't reject the null hypothesis when you should have, that's not as clear-cut to find because it's affected by your sample size, your effect size, your variability, and your significance level. Typically, alpha is going to be 0.05, unless it's really bad if you would make that type of mistake. Then you would go ahead and change alpha to 0.01 or something more extreme. Now, for the most part, if the type 2 error is a worse mistake to make, you would raise your alpha to like 0.1 or 10%. So the results are statistically significant if your p-value is less than alpha. We would reject your null hypothesis if your p-value is less than alpha. If that's a false statement, then it's not true and you do not reject. Rejecting your null hypothesis is not the same as accepting it. And then we actually have 2 types of errors, a type 1 error and a type 2 error. that could be